I start streaming and then I will know how bad the microphone will be later. So it's on my YouTube account. I will share the link later, or you can find the YouTube. So little inception going on currently. Okay, what's our topic? So we are switching gears and you're going for part 3. I actually sort of envisioned this course and everyone finishing before the year changes. No picture on the screen. Why though? I didn't see my YouTube live stream inception. I wonder, did my stream break now? I guess not. Maybe not. So yeah, I'm streaming on YouTube. Trying new things. Where is it? Yeah, it seems to be working. So we are switching gears, part 3. Part 1, we built a project. Some teams more successfully, some teams less successfully. Part 2, we did a little rendezvous with Selenium and Cypress. And now part 3, we are going to continue with what we did in part 1, but we're going to put it on the server. Let's look at the points real quick. Maybe sometime later I will introduce points again in more detail. Maybe they need some refreshing. They probably need some refreshing, because I refreshed points in the other project, which has similar structure, but not other project, other subject has a bit similar structure. Yes, I think I will need to update the configuration. I have started, I don't know if that is interesting, but I have started adding disqualifications inside the project. Well, sorry, this link. To make it more visually discernible. So things like adding a reason for disqualification and then referencing that inside the code. Well, we'll have to think about it. But yes, for part 3, we'll need to have your own server. To help you acquire a server, there is a link to the GitHub Education student pack. So if you register with Taltech email, you automatically get different goodies. So 50 euros at DigitalOcean, 100 euros at Azure, and others. AWS should be also here somewhere. Anyways, you have free money, Twilio, many. Oh, config cat. Learn feature flags if industry leading feature flag service. Well, to be honest, I don't know these at all, but I'm just scrolling and looks like there are, AWS was the last one. There's a lot you can get for free being a student, because we just want you to become a developer, do startups or other things. And this guide is also needs a little refreshing up, but we are not doing front end because you don't have front end. Last year we had an optional front end, but we switched it with more focus on Selenium and Selenite. So we just need to configure our backend on the server. Simple as that.
But this backend API, we have something like Swagger UI, right? Isn't it like front end, or I'm not sure how this whole thing works?
Sure, yeah, we can think of Swagger UI as front end, and we can say that this will also be on the server.
Okay.
Yeah, and part 3 will end with a defense, so part 2 does not have a defense. Ends at defense, and then you get your final grade. Put all the points together, divide by max points, and you get the grade. Okay. So we need to set up a server. In the class I am gonna be showing AWS. All AWS guides are here. So let's begin somewhere. So let's have aws.com. I think you need to register your credit card or debit card, but that's okay. You should not be charged, or if you will be charged, that will be below 10, most likely below 5 euros. You open the console after you log in, switch the region to something that's near you. So I recommend you switch to Stockholm. Well, the reason being that the closer it is, it's still the bytes have to travel, right? Sorry. The bytes have to travel, and the less the bytes have to travel, the faster it's gonna be. So Stockholm. And you look at the left side, there are instances. So EC2 is what we want to look for. So we want to EC2. EC2 stands for, don't know what it stands for, but it's for a virtual machine. We're gonna get the virtual machine for ourselves. We're gonna have an instance, and then we're gonna launch an instance, I suppose. There is a guide for it here, so how to do. So we are doing Ubuntu 20.04. We are doing the one that's free tier. And then we're gonna start, pick that, then we click next till we reach storage. So next storage. You want to have storage so you're not I don't know, around 15. We're gonna add some as virtual memory. So 16 it says here. Okay. Maybe even 8 will suffice. Well, it depends how much you will be logging and doing. Okay, let's next. Now security group. We want to make the service visible to the outside world. Currently it's only open to SSH. Do you know SSH?
SSH?
Yes.
Yes, secure shell.
Yeah, it's secure shell, so that's only for connecting like SSH to the place. But you want to also connect to it from the browser. So from the browser we need to have a different network, I mean rule at least. So all traffic source. If you don't do it now, it's gonna be annoying to do it later. And that's it, I think. Review and launch. You will need a public and private key. So I know you're cybersecurity students, you should know what a public or private key is, but well, it's it's a pair of keys. So one of them is public. The public key is visible to everyone, and it's I know it's like a secure code that tells you who you are, and your private key. Only through your private key you can it will recognize you. So your computer has the private key, the public key will be on the server, and you can generate the public key from the private key. So it should be like a key identifier. That was way too many words.
So you generate public key from private key.
Well, they generate it together, but
yeah, I know, like we derive it.
Yeah, derive it. Yeah, they derive the value. Because well, we can public key is just a long hash. So I have an existing key pair here. Hopefully that's the correct one. Well, if it's not, then there is also like an option you create new one and then you create it here. Usually you just have one and then reuse it. Otherwise it's your own time effort. So in Linux and probably Mac they're kept here. And the public key, so cat. Let's look at the RSA key. So this is what the public key looks like. It's not just a hash. And at the end there is a little comment, a little hint for you, for me, for everyone to understand whose key is it. Because if you have a long server file, let's look at one. So in the other class I have a team of mentors. So it looks something, the file would look something like this, and it's very nice to have here at the end the names, so you can understand who are these from. I went too fast, but I mean you get the idea. At the end there is a name. You know who it's from. Well, this one I don't know who it's from. Naughty, I don't know whom to remove. Who will it be? But all the other ones have sort of some reference to the person's name, and then I know myself who they are. Okay, the instance gets itself here into instances. I recommend you add a name for it. Because it's very easy to confuse, especially if you have multiple. It's running, so I want to connect to it. So you clicked here a connect button, and it will not connect to it, but it will show you options how to connect. Basically, if you are on Unix, which is on Linux or Mac, your life is good. If you are on Windows, your life is terrible. But you have PuTTY client, and they should, I think for Windows they will have a guide here, so don't worry, this PuTTY is not that bad. I have had Windows myself and I've managed to do it. Well, here is one of the links to connect. This link won't work for me, don't remember why. Because it's not where my public key is located. I think I have to do no such file or directory. I don't remember what I did, but if I go to SSH catalog, I could. It's not my default key, so your system, I mean, not sure about Windows, but like Unix has a default key for some permission denied.
It has to be like /.ssh/ so we go from root directory.
No, mine apparently doesn't have an @ that was the reason why. So it should work now. So I didn't have an @.
Oh yeah.
That was the problem there. Okay. So the first thing that I would do, go to SSH, look at the authorized keys, and because it's my user, I don't need sudo. I think I can add my regular public SSH key, or you would add your friend's keys, and you would also add your favorite lecturer keys, which is me. So you go under the mentors, there is file of SSH keys, you just copy, shift insert on this third of terminals and add it, save it, just happened to say I don't know why. And let's copy it again. And you're logging in as Ubuntu, so Ubuntu at this user, and I logged in. So we're using my other key, so I added myself. In your case, your friend would be able to access it. You want your friends, I mean, you don't want all of your friends, but you want your teammates to access it. Because maybe your friends are thinking that they're very funny and they're gonna drop your application. Well, we have the server, we have acquired the server. Let's talk a little bit about the pipeline and maybe finish the installation next time. Like, let's talk about like what are we trying to do. And let's talk about, it seems to me like I'm a bit over the place, so I have to apologize for that. And let's talk about what's the most important thing when you're, what do you think, what's the most important thing when you're installing a server?
Make it up and running.
The most important thing when running a server is installation guide.
Oh yeah.
So installation guide, I will have to update these. I have what is it? I have improved my Excel design skills with making some things bold. So an installation guide, and I will add here also like a components diagram, but I will do that later. I sort of, yeah, but I can show you what the component diagram looks like. So like a little teaser. So why I'm adding a component diagram, but this is now with a front end as well. And this example is for, so heroes, Hero OS 2020 ML. Error. Interesting, but I don't know, it works or it didn't. But this is the website I was configuring for my other course. Here sort of courses sort of like interact with one another. A lot of the similarities, but also differences. So this has a front end, and we also have some sort of back end where we return the list of heroes. Yeah, so it's a list of heroes. And this is them. This is just some basic front end, and that looks, when we install that, it looks something like this. I'm gonna have a similar diagram for our subject, for our testing course. It's roughly what it is here, but we don't have front end. So we have only one repository. So although we have same number of developers, and we're gonna use a GitLab runner, which is our CI/CD tool, continuous integration, continuous delivery. We have to talk about what these words mean. What do these words mean? But our application is gonna be packed into a backend jar, and then we're gonna serve it through Nginx. Why we'll serve it through Nginx will make sense, and then the user can access it on the web page, like so. Okay, so it's like in few words. There's a little description as well. Description will be also mandatory, together with the picture. The picture, you can say that one picture is worth 1,000 words, but in this case you also add a few hundred extra words. Well, this sort of logic applies to every type of application. So for front end, in the other course we are using Node and Angular, so they pack themselves to static files, and they are also can be searched through Nginx. Similar thing with whatever you're doing, C#, Pythons, etc. There is some sort of code. Code needs to be compiled and tested, and then that result will be set on the server where it is served through, like, each language has their own specific way how they're served, but that's the main idea. Am I forgetting anything? So we will make everything run in this singular AWS EC2 instance. And the backend you can put into Docker if you want. You can also do other shenanigans. We are gonna look at them later. So right now we want to look at like a little history maybe of how the applications were deployed. So currently your applications are running locally, right? But you would like it to be somewhere on the server. So well, this rack is probably, what is a server? I'm like, it's just a machine. Similar, they look similar to gaming PCs because they don't have to look pretty, and they don't have to be transportable. You just sort of, if it stays, it stays. And they used to be physical. Well, you can probably guess what the problem now that you've been using the cloud. Like, they have physical servers are not used for like 20 years, so I think you can guess, like, let's say not used, like mostly not used, like preferred, not preferred, because maybe you want to have, I mean, in the end the cloud runs on physical servers. Somewhere somebody has to have physical servers. So if Google data centers, all these servers, they at the end, the companies that provide the cloud, the Azure, the Microsoft, the AWS, they have the cloud runs on this server farm. So it has a huge, there is a huge supply of machines there. Yeah, there's a huge supply of machines. So the cloud runs on physical servers. So, but you yourself don't want to manage physical servers, because physical servers can break. Physical servers, I mean, you buy the whole thing, maybe you just need a tiny bit. Maybe you need the application to run once a month, and then it's down. All the rest, like payment calculation. Anyways, the physical server has so many drawbacks that they were replaced with virtual machines.
So now mid-range companies use cloud servers, right?
So the question was, does the mid-level company use cloud service? Yes, I think even if they have infra in-house, even though infra does not provide physical machines, but they provide some sort of virtualizations on the physical machines. So everything is virtualized. Okay, that's a good one. So from that we transitioned to a virtual machine, and now that one is backed by physical servers. I mean, the physical servers, how do I move this? Cursed. The physical servers also backed virtual machines. So compared to a physical server, virtual machine is always the same. It's already set up. There are no differences. You're not using one hardware versus the other hardware. This has been all sort of abstracted out. So your virtual machine is exactly what you get. We did some virtual machine setup. We are using Ubuntu 20 04. So you saw how easy and how fast we got it. Alternative would be that we would have a separate machine here, or like we would have a Raspberry Pi or something small. It doesn't have to be like big. It's a small machine. We would connect it. We would install Ubuntu on it, etc. Let's see, maybe it would work, maybe it wouldn't work. But here, virtual machine is already pre-packed with Ubuntu, so life's good with virtual machines. I mean, life was good, then was better, but the things change, people optimize, and when is Docker from? I wonder. Docker. See, Docker is from 2013, so Docker's maybe 2015, 2017, 18, Dockers become mainstream, and just from these years, it's very recent development. So Docker is the next level. Now with us, if you look at our machine, we are installing on virtual machine, and we can install their Docker, but we can also use old school ways, like executing jars manually. In relation, when we talk about Java, but Docker, you will look at Docker is a smaller package of virtual machine. So just it has pre-installed only the things that you need for that Docker. So some examples. So let's say we need JRE image later. So Java runtime environment. So I googled, and I see here okay, they have too many tags. They've been busy doing releases. Must be not easy to be their developer. But we will use 11 because 11 is the latest. And we need JRE, so I'll probably use something like this. Slim even. Slim is slimmed down version. So let's make it visible. Just so we would use that sort of image. So that's sort of like latest. 11 was LTS, latest long-term support. It's probably some should be something shorter. Okay, so then yeah, we'll be using Docker. But going back like to the benefits, the Docker is smaller than virtual machine, and then as a container Docker, I think with virtual machines you could also spin up virtual machines and shut down virtual machines. Like you could have some sort of tools with virtual machines, but the Docker tools, which is the most popular one of these is Kubernetes. So this is the most popular tool with Docker. This sort of sailor icon. So this would spin up the different machines underneath. Like the architecture, I showed you component diagram, but usually let me talk about like what's going on today and what's going to happen this week. So we have a front end as an application, then you have your API, You did your finance API, so we did finance API. And there's gonna be like API 2. And let's add a database. So typical database. Let's make it, put everything together. I'm not gonna draw arrows, but the flow would be from the left to the right and back. So front end would query some data. Now this is okay design for a simple page, but let's say you have something more serious. Then you would have multiple instances, at least you would have at least 2 instances of everything, or even you would have more instances. So we have, what's it, 5 instances of API 2 and 3 instances of finance API. We have 2 front ends. Now why am I drawing this?
Sorry, what is API?
It's like just it's another API. This is like what we have, finance API.
Oh yeah.
But this is like some other API. There could be some more APIs, but just to simplify, we're just gonna have these 2 APIs. They actually, the names sort of aren't important. So this is like one API, the other one is other API, and let's say this is just, there's only one front end. Like there's no mobile app. If there were a mobile app, it would be different. If it would be some sort of enterprise application, it would be another front end. But here, well, today we have in Estonia, we have like esmaspäev, which is like crazy discounts, but probably not as crazy when you think about AliExpress. On the other hand, then in 2 days on Wednesday there is 11/11 sale. We have 1 student in the classroom. What do you think, how much revenue will it generate? Did it generate last year?
You mean,
Singles Day.
You mean like how much more income it gets? Or
Yeah, how much revenue, yeah, income did it get?
like the AliExpress?
Yes, from 1 day, 11/11.
I think about 15%.
Tell me, give me an absolute number. Give me billions.
2 millions.
2 billions?
Millions.
Millions?
Yeah.
Where have you been living?
I'm not sure. Like,
AliExpress.
there are not so many people ordering like from Europe, the rest of the world, only China, Asia. So I thought.
AliExpress. I just googled it, 11th sale. Sale, okay, record. What's that? Maybe that will give me.
Gosh. 24 hours.
In 24 hours. Actually, I found earlier that it was 20 billies, but apparently it's almost 40 billies. So they're expecting to probably get another record, because like with AliExpress you can tell that you want to buy things but pay on that day, on the 11th. So that's almost 40 billies. Let's put it to the scale. What do you think GDP of Estonia is?
Gosh, a couple of billions.
Is it bigger and smaller?
No, it should be bigger actually. No, it has to be. The entire country. Right? Oh my god.
So, yeah, now we're talking about the scale. So Estonian GDP is 30 billies. Well, it's 2018. No, well, could be anything really. But the AliExpress was bigger in 24 hours, in 1 day. Well, maybe it's like over multiple days here. But yeah. In 24 hours, selling more than half of what Amazon sells in the entire quarter.
Yes.
Anyways, this day is crazy, and not only crazy from the amounts the crazy from, I mean, the AliExpress doesn't run on thin air. It runs on applications. So what happens on on AliExpress on the Singles Day is that there is a, let's say they're using Kubernetes and these are all images. The Kubernetes manages load. So when you have people are coming in, they start increasing everything. So they put more instances of this, they put more instances of the other API, they put more instances of front end, and then this way they will manage the load. So as you have the spikes of the traffic are coming in, you will get more and more applications online. This is, what is it, parallel horizontal scaling. So in the horizon you're scaling, putting applications one against the other. So your finance, mostly your finance APIs, they don't have any state in them, so they could be very easily, you could put like 2 or 3 of them separately and you would have a multiple instances of them. Now how you manage these instances is with a concept known as, I don't know, maybe you know what kind of concepts. Rectangle. Do initials LB tell you anything? So load balancer. So you would have a load balancer. A load balancer would like sort of picks one of these APIs. So for example, one API is doing some sort of order, then it's busy, you pass on to the other one. Or one is doing like from one API you are buying. You're only buying, what could you buy from China? You're buying yourself napkins. And the other guy is buying like headphones and electric scooter and typical things like mouses and holders and power bricks and cables. So his order would take longer than the other order. You have to, well, it's easy for me to say, but you have to imagine like it's the logic. What happens here is much more complex. First you pick an order, then you click OK. Then it starts processing. Now processing, there are multiple stages. There is you need to pay for it, and it has to successfully pay. Like payment has to work. And then later it is sent to the. In AliExpress, there's like, it's a platform for other shops. So the other shop will have to prepare your order, pack it, send it, and give you this code. This code has to reach the web page so you can again observe it. So different, these communications between, so like back-end process is much more complex than the front end would assume. Like this is the typical backend thing, that the backend systems, there's one front end, but there are multiple different backend systems at the back. And how they are connected to something else, it's all, well, you would have the load balancers then, I suppose, everywhere. And when you have multiple applications together, it can, like here we have the APIs. You can think of it as a cluster. The cluster is a word that is used to describe this sort of a cluster of applications. You will also have similar thing with the database. Either you have your on your own, or you have it acquired it as a service. So AWS provides a thing known as RDS, which is Cloud Relational Database. So the database, you just register there, you get the URL, you connect to it, you have your database instance. You don't have to start it locally, you don't have to mess around. Everything is simple. The only thing is that it costs, but you know, you always pay for simplicity.
I mean, when they sell something, when goods in one day, they can pay for it, I guess.
Yeah, but there, yeah. And the Netflix is also on AWS. Yeah, a lot of infrastructure is on the cloud, so AWS has 1/3 of the market share. Azure has 1/2 of 1/3, so together they have like a half, and then the other players have the rest. There are quite a few other players. Google, of course, then Facebook has something. Cloud, DigitalOcean, but there are like later it's less and less. The IBMs and Oracles, and they all like, everybody provides something for different segment of the market. Yeah, if you have like big companies, they want to deal with another big company. They don't want to deal like with a simple startup. Not saying that there, none of these that I mentioned before are simple startups. Okay, so that takes us to what's happening today. With our application, we have to drawing. We have this GitLab runner. Now this is very often in a separate server, and it will be called then build server. And then the other, where the application is, it's a production server, assuming that your like production is all together in one server. But for simple applications like yours, for this, I know, mom and pop shops and etc., this is like more than enough. And when you look at our specs of our machine, we had it open somewhere. I closed it. Our specs of our machine are not very high. They're actually pretty bad. But there is difference. You're used to, well, the phone blows away that machine that we have. Let's look at it again. So I have to tell you, this AWS user face has gotten better than last year, but it's still terrible. So if you're having trouble, welcome to the club. So let's look at the instances that are running. So this is, I wonder where can I see some specs. So it's micro. We saw specs when we were creating, so let's open that create window if I can find it. Okay, let's look. It was here, yeah. So micro, we had micro before. So we have 2 CPUs, and memory is 1 GB. So that's RAM. The other memory, like this on the space memory, how much free space, it's usually provided differently. It's like sort of plugged in inside the other application, like as a separate drive. That way you have more, yeah, you have like separation between one and the other. Sometimes you need a lot of memory, but you have a weak like small application, but it just creates a lot of file. It just logs all the time. It has to log everything down. Let's say it's a requirement, logs everything down. It says everything down. It just creates and creates and creates space. The other alternative would be you need something real fast that handles billions of data, but it doesn't need to log everything, so it doesn't need any space. So yeah, this application is, I mean, when comparing to all the gaming PCs, this is nothing. And this application here, the one I was demoing, also doesn't, it runs on that setup, it doesn't do anything. It's snappy, but just no problems whatsoever. So yeah, the fact that these machines for your applications require very little config, like very little memory and stuff. However, we might need more memory for our tests that we will run later. So let's add, I will have this guide here. I will need to clean up, but I have it for the other course. So this is where I'm gonna be taking it from. So if you use htop, it will show you how much memory do we have. So I'm gonna look at my computer. I have, well, my CPUs are busy because I am recording. Also nice for my hands, nice and warm. In this room it's usually quite cold. We had somewhere, yeah, it's the IP. So, and this is like, we have 2 cores, that's better than 1, and we have, well, I have locally, I have 24 gigabytes of RAM. Nice, and I have some swap. Now swap is known as virtual memory, so if you run out of memory, then you can take from the swap. So we will use the same, well, I have IntelliJ running. IntelliJ is like half, like 15, 13 gigabytes immediately. Also I have multiple projects running probably. I have, while I'm grading and I'm working, I sometimes end up with 8 or 10 projects, but it's the IntelliJ style. With other programs you would, I mean, in the old days I used to have Eclipse, and then you would have one Eclipse window and you would have multiple sub-projects. With IntelliJ you always open it into new projects. I don't know how it's with VS Code, haven't used that. But our goal here is to add some swap so we could survive. Well, this build said we could survive Angular build, but we don't have that front-end problem here. So we know Angular just eats the Gradle build. It survives fine, but I don't know, maybe we'll have some tests that who knows.
Our project is very simple. Why do we need swap?
Let's just add it just in case if anyone will start running out of memory, we will just tell them that this is how you add swap. So I just do it. And I basically copy paste commands. I see that I created a swap file, and this will like make it permanent, the last command. And if I so I look htop, now I have some swap here, and if I sudo reboot, then next time I log in, we should have everything. I think that we will leave GitLab runner installation for the next time. So we'll have everything. Yeah, the next time will be compact. We're just gonna do GitLab runner. I'm gonna just show you locally some things. Are we okay? So it's in, and we have htop. I'm just gonna show you how do you run Java applications, how do you pack them. And I think we ended there, so let's not, otherwise the third part ends too soon, and what do we do then? Okay, I have my other application running. And then I will work on the points this weekend, and then we'll have part 3 updated. I can demo the points as well. So we'll be working only on the backend API. You don't need the Selenium Cypress. You don't need to stick them into the server. Have some theory here. Let's work like this. Probably because I have added them to Git. If I yeah, nice small screen. Git rollback. Okay, now they're excluded. Okay, so we had an application. Let's, on the right side we have Gradle, and we haven't really looked at it. So it has this, we did answer, you're going to answer me about what Gradle is, but here are different builds it can do. And one of them is clean, and the clean cleans up everything. So let's do the build. Build sort of builds it all. We're also running tests. There is an option we could have run assemble. So assemble is without tests and very few. And the check, I mean the build consists of assemble and the check. Assembling is just building it without tests, and check is checking it without assembling. It's just Gradle provides, compared to Maven, Gradle provides more flexibility of how the builds are defined. Oh, I have some null pointer exceptions. So I'm just gonna go with assemble. And then let's see what the build we have under the build. Now we have this jar file. We can, I mean the jar file is ICS00, no, yeah, 2020 backend API, and then at the end we have 0.0.1 snapshot. That's okay, but I sort of like it something nicer. Well, you can Google, you can take it from a different project if you have done it somewhere. I know that there is this command, so we can config in build Gradle what the jar file is gonna be like. We can also config it to be a different. The applications in Java can be packaged into two. Well, they can be packaged into more things, but what the ones I know are var, which is like war, and jar, which is jar. And well, they're different. They will be deployed differently. There are also some other styles. It's just jar file is easier to deploy because it currently has, we have everything in it. We have embedded Tomcat, we have we have embedded web server, which is Tomcat in there. I just noticed that its name is we could have something better backend. Let's have it finance API. So we're gonna have a better name, and then I'm just gonna show you how we can run the jar, and we are gonna stop the lesson. And then the next lesson, and I'll show you how to, I'll show you one more thing. And then will show you how to do things better. Okay, so now we have multiple different files there. Let's go and explore. So it's in build folder. I'm gonna run it in libs. So java -char finance API. I run it. So java -char. Like the prerequisite is that we have Java installed, which in our own local machine where we are using JDK, it is installed. But if you have fresh server, fresh install, and we don't have Java, so just a thing to pay attention to. So, and it ran, if I remember correctly, on localhost 8080. Is that true? Finance. Let's look at application YAML. So default port 8080. Okay. So API is up. Now we could do. I remember we had this custom YAML. Now I'm gonna show you that you can overwrite that config. I think you can override the port. Wait, sorry, that's wrong application. Yeah, I was not closing apps before coming here. So I think it is server port. So port is 8080, and we're gonna say something else. We're gonna say 8070. However, we don't want this port to be changed all the time. We just want to change it for our execution. So we could do that in two ways. Where's that application? Ah, yeah, it was in the terminal. Right. So it's right here. So instead of java -char, we could also write -d server port 8050. Maybe it will work. Does it show me the... See, it said port Tomcat started at port 8050. So I had just overridden the port. So 8080 gives an error, but 8050 works. Well, this is how you would override single property, but that's... So what I did was I set -d and then property name. Usually instead of that you would use spring config location and then point to the config file. So you would have your own config file. So we have application YAML, but also here I showed you this. I had custom YAML where I had the Alpha Vantage real, my super secret key, which I didn't want you to see. So we could reference here, because we are in this example, we are in the build folder, and we are in the libs folder. We should go libs up one more, and custom YAML. And if it works, magic. If it doesn't, it's okay, because on the server you can manage it better. You can have custom config in the same file as the char, so in the same folder as the char, so it's much easier for you to set it up. So it's at 8080 now, back to there. Finance, symbol Apple. and it broke. We got some null pointer. I don't know, maybe something changed with alpha vantage, but I think myself that it's not, it's something we broke. The service, the config itself probably works, so alpha vantage currently, or like something there, because we do still have our homepage open up, or no? I just closed it like genius. But yes, anyways, we started the jar. It got us application. Now what we would like to do is, how would you run it on the server? You would take this jar and put it on the server. So we just need to, so we are on the, that's not server. So we are on the server. So I would take this jar file, I would copy this finance to this Ubuntu. You don't need to do this, I'm just showing you as an example. Okay, let me see. I go back to Ubuntu. I should be at home. Didn't work. Why? Okay. Oh, quick Google will probably fix it. SCP example. But just copy is secure copy. It's like, okay, it's the reverse. Wait, from localhost. I have to add some directory. Okay. So, like so. Il Magico. I go back to the server. It's in my home. I have the jar file, java -jar finance api.jar. Don't have the java. Okay, let's quickly install. Didn't want to get into the install, but looks like I have to. So let's install both OpenJDK and, well, let's do the upgrade and OpenJDK, then we can run the thing and then we are done for today. So update is like check for updates, upgrade is actual, like do the upgrades. There might be some security updates, etc. It depends how far is it from, like when did you take the machine, what's the machine update date compared to how much time has elapsed. The security updates come all the time. You have to update your machine every now and then. That's the administrator job. You're doing a little bit of server-side administration. Some other people, they discover bugs in their code or discovered security leaks, then they fix them, and you want to get the updates. These should be these sort of secure updates without breaking anything, right? If if you download updates and it breaks your system, that's not what you want. So little bit of updates and then install and run the jar file. Okay, while it's installing these, our application, our AWS has a public IP. So when we look at the instance, which one is that? The last one. Here is a public IP. So copy paste. Currently there's nothing. Okay, it's installing. Take your time, it's not like we have lesson to finish or anything. Okay, finished installing JDK, JRE and JDK. JDK we do not need now, but we will need it for our install. Quite busy here. And now we can run java-jar finance API.jar and the application starts on the server. And if we go to the IP, and remember we had port, the IP itself doesn't work, but we had port 8080. So if you open that, it shows that the API is up. Okay, I'm gonna stop now. So we got the application up. We started with an empty machine. We haven't set up there anything, we just copied our jar file. We are gonna improve on the next lesson. We're not gonna copy manually the jar files. We're gonna have a process and we're gonna talk about what that process is. And then we're gonna see further. Okay. Dankeschön.